Let's look at this little different problem. This is a heat of neutralization reaction. And so in the heat of neutralization, you have to have an acid and a base. Okay, so here we have a 50 milliliter sample of 0.50 milliliter sample of 0.250 molar HCl, and the initial temperature is 19.50 degrees Celsius, and it's added to also 50 milliliters of 0.25 molar sodium hydroxide, which is also at 19.5 degrees Celsius. So when they are added in a calorimeter, the temperature rises to 21.21 degrees Celsius. So that's T final, this is T initial for the reaction. And we're supposed to calculate the delta H for this reaction. Now remember, HCl plus NaOH to give you NaCl plus H2O. So when we have to calculate delta H for these reactions, it has to be joules or kilojoules per mole. The important thing is the moles, of course. You can't just have it as heat capacity, which means in grams or without grams or without moles. Okay, so you have to have per mole over here. So let's get started. A few assumptions that we have to make over here is that 50.0 milliliters plus 50.0 milliliters is total of 100 milliliters. That is one assumption. In some cases, solutions are not additive, but we are going to go with the fact that they are additive and the fact that their density has not changed. Okay, so 1 gram per 1 milliliter, so which means that we have 100 grams of solution. That is one assumption that we have to make. The second assumption that we have to make is the specific heat of water. Okay, because technically speaking, this is not water anymore. It's actually a solution of acid base, but we are going to go ahead and assume that we still have water. So the specific heat is going to be 4.18. So those are the two assumptions we'll make. The rest of it is going to be the same. All right, so our calculations remain the same. So for example, let's go ahead and find the heat released in the calorimeter, and that's going to be mass, specific heat, and then of course delta T. So the mass is 100 grams. Specific heat is 4.18 joules per gram degree Celsius, and then the temperature change is going to be 21.21 minus 19.50 degrees Celsius. Okay, so that means that the heat released over here, or the heat absorbed by the calorimeter, is 715 joules. Okay, that we have, and this is again heat absorbed by the calorimeter. All right, that's the Qcal. So then Qcal, or the Q reaction, is equal to minus Q calorimeter, because if the calorimeter is absorbing the heat, the reaction must be giving off the heat, so which means that our number is 715 joules, but negative sign over here. Okay, so this is the heat of reaction then. Okay, not delta H yet, but this is the heat of reaction. So that's one part of this calculation. The second part of the calculation for all of this, so second part is now trying to find out the delta H, okay, which is joules per mole. So now we have to find out the moles of the reaction. To find the moles of HCl, now for this one you have to write the equation. Okay, so 0.0500 or 0, doesn't matter, liters, convert it to liters because you're trying to find moles, and remember molarity is moles over liter, so moles is equal to molarity times liters. Okay, so we're multiplying the liters, and the molarity of this is 0.25, okay, which is moles per liter, and this is equal to 0.0125 moles of HCl. Okay, you also want to find out the moles for NaOH. And in this case, you really can skip this step if you want to, because you know that both numbers are the same. If both numbers were not the same, then this step would be worthwhile. Okay, but if both numbers are the same, then you can skip it. Okay, but the other thing you would need to do after calculating for the moles of both of them is to do a mole ratio. Okay, because since this is a stoichiometric thing and you have to find the moles, you have to do the mole ratio. So whether you take 0.125 moles of HCl or 0.125 moles of NaOH, it doesn't matter because they're both the same. All you want to make sure is that you do the mole ratio with 1 mole, say H2O, pick any product you want to, and then 1 mole HCl. Okay, that is your mole ratio, so it's going to be the same, and you can do it with the other one also. So 0.0125 moles of H2O, so which means that this is going to be your mole answer. So then the delta H for the reaction is going to be minus 715 joules divided by the moles, which is 0.0125 moles. Okay, and this will give you minus 5.72 10 to the power of 4 joules. And if you want to convert that to kilojoules, you're most welcome to do that. So 57.2 kilojoules, and the answer is negative because heat was given off in this reaction.